Okay, guys, hello, finite math students. This is Mr. Lewitt. I'm going to record another linear programming tutorial video for you. What I want to concentrate on, I'm hoping that most of you in the class are already done with most of your maximization problems. I'm hoping that you are now getting into the minimization problems in your homework, and I believe that's the next section. That's the next section of your chapter, and that should also be the next section of your homework assignment. So what I would like to do is work on a couple of those problems and show you how you can use Mathematica to solve those problems. Now, this is important, guys. Mathematica is not a substitute for your own brain. Mathematica is not going to do all of the work for you. You still have to do a lot of the work yourself. Okay? A couple students emailed me and they asked me, well, how can I get Mathematica to just solve the whole problem for me? Well, I'm sorry, but that's not what we're using Mathematica for. It's not a substitute for your brain. Okay, you still have to study. What Mathematica does is it helps you organize your numerical data in the form of a matrix that is easy for you to read and should be easy for you to manipulate. But Mathematica isn't going to do the entire problem for you. You still have to do some good old-fashioned thinking and reasoning. Okay, so let's look at a couple of these problems. Okay, these are minimization problems rather than maximization problems, and we're going to solve them using something called duality. It's really not hard. It's pretty easy, and you just have to remember a couple of rules, and that's it. So I'm looking right now at problem number 66. It says minimize C, and the reason they like to use C for the name of the objective function is because in the context of linear programming, a lot of minimization problems are based on cost functions. You're trying to minimize a cost. Just like in the last section, you were working on maximizing a profit. So this time we're minimizing a cost, and of course the word cost begins with the letter C. Okay, so it makes sense, within this context, a lot of the functions, a lot of the objective functions, the dependent variable is labeled capital C. It doesn't have to be. That's just a convention. Okay? So, let's see. Form the dual problem. So here in the minimization problem, right, we have x1 and x2. So in the dual problem, we have y1 and y2. But remember, the y1 and y2, they have to do with the number of constraints. The reason why we have two y variables, y1 and y2, it's because we have these two constraints. That's the real reason, okay? It's not because of x1 and x2 up here. So don't get that confused, all right? Okay, so these numbers here are actually coming from the resource values on the right-hand side of those inequalities. Okay, so once again, these numbers or coefficients are coming from the resource values that you will find on the right-hand sides of these inequalities. And we're not going to worry about these inequalities because these inequalities are basically a given in practically every single linear programming problem that we do. Okay, so, we're not going to worry too much about these inequalities right now. Okay, let's see. So that's going to be a 2, and this is going to be 3. Okay, we're reading down the columns, and this is going to be 1, and this is going to be -2. Oh, and this one, let me see, 28. Okay, and that's correct. Find the solution to the original problem by applying the simplex method to the dual problem. Select the correct choice below and fill in any answer boxes within your choice. Okay, so let's see. Let's see what we have here. Okay, so we have... Now, what I'm going to... Well, okay, let's just do this directly. I was thinking of making this a little fancier, but let's just be very direct about this. So, my matrix is 3, -10, 28, 1, -2, 36. Okay. And then we look at this function on top. So that's going to be -2, -7. Oh, you know what I'm forgetting? Hold on one second. Sorry. Actually, hold on. I'm going to start over again. Okay, 3, -10, 1, -2, -2, -7. Okay, so we have the values 3, -10, 1, -2, -2, -7. Remember, I realize that this is a +2 and a +7, but when you take these numbers to the other side of the equal sign, their signs change from positive to negative. Okay, so this matrix has 3 rows. The matrix has 3 rows. This is row 1, this is row 2, this is row 3, which means I need to augment this matrix with a 3 by 3 identity matrix, okay, which looks like this. Okay, one second. There we go. It looks like that. And then I need to also include those resource values. So that's going to be 28 and then 36. And of course, here you're going to have 0 at the bottom. Okay. Okay. And the reason you have 0 is because if you look at your p function, okay, so you have p is equal to 2y1 plus 7y2. Well, what are the values of y1 and y2? This is the y1 column, this is the y2 column. Those are non-basic columns. Okay, and those are non-basic columns. This is the y1 column, right? And this is the y2 column. These are non-basic columns. Okay, so remember from the last section, if a variable is represented by a non-basic column, what is the default value of that variable? Well, it's going to be 0. If a variable is represented by a non-basic column, what is the value of the variable? It's going to be 0. So then you have 2 times 0 plus 7 times 0. Okay, and what does that equal? That has to equal 0. So that's why you have the 0 here. Okay? Let's see. So A is equal to join A, identity matrix 3, and then 28, 36, 0. And don't forget the number 2, because we're not just joining lists. We're joining matrices, which are nested lists. So you can't forget the number 2. Let's make sure it looks okay. Okay, terrific. So this is very similar to what we did in the last section. Okay, so the problem here, excuse me, normally I would say, you're supposed to pivot in this column right here because -7 is more negative than -2. But the problem is you cannot pivot on negative values. All right, you cannot pivot on negative values. That's going to cause some real problems. So then we're going to have to pivot in this column right over here. All right, so let's find our ratios. 28 divided by 3 is 9.333, and 36 divided by 1, of course, is 36. Which one is smaller, 9.333 or 36? Okay, so this is the smaller ratio, which means we're going to have to pivot right over there. All right, so let's start pivoting. We're manipulating the first row of the matrix. Okay, that's a 3. That's a 3. I want that to be the number 1. How do you change it into the number 1? You multiply by the reciprocal. So 1/3 times the first row of A, and let's see what we have. Okay, that looks good. And then the second row is, like, this has to be a 0, right? That has to be a 0, and I know that 1 minus 1 is 0. 1 minus 1 is 0. Okay, so the second row is going to be the second row minus the first row. Okay, and then what about the third row? Well, that's a -2, but I want this to be a 0. So how do I get rid of the -2? So the third row is equal to the third row plus 2 times the first row. Okay, so then we want to know where are we supposed to pivot. So remember the rule, look for negative numbers in the bottom row. Look for negative numbers in the bottom row. Well, I see a negative number right over here. So I know you cannot pivot on a negative value, so we have no choice. We have to pivot right over there. Okay, we're going to pivot right over here on the 4/3. Okay? Okay, so we're manipulating the second row this time, and that's going to be, the reciprocal of 4/3 is 3/4, and that's going to be, let's see, okay, that looks great. So this is going to have to become a 0, right? And that has to become a 0. Okay, so then we're going to change the first row. The new first row is the old first row plus 10/3 times the second row. Okay. And then we have to get rid of that negative 41 over 3. We have to replace it with 0. So we're changing the third row, and that's going to be the third row plus 41 over 3 times the second row. Okay, so now we have a real issue because we have a negative. The only negative number that we find in the bottom row belongs to this column. The only negative number that we can see in the bottom row belongs to this column, but all the numbers are negative. All of these numbers, we can't pivot on them. We can't pivot on them, which means that there is no solution. The optimal solution does not exist. And the reason it does not exist, well, hold on, let me make sure I have the right answer, okay? What does Pearson say? Okay, so the reason, let me explain this a little more carefully. So, remember, you're supposed to pivot, excuse me, you're supposed to pivot in a column that has a negative number in the bottom row. But all these numbers are negative. There's nowhere to pivot, which means there is no optimal solution. There is no optimal solution. There is no minimum solution. Okay? So, yeah, and that's the right answer. This is similar, but let's try a different one. Okay, that's my dog. Chachki, stop. That's my dog, guys. Sorry about that, but there's nothing I can do about that. Okay, let's see if we can find a word problem. Let's see if we can find... It would be nice to find a word problem, but I think that's a little later on in your homework. Okay, I'll tell you what. Let's do problem 77. We're gonna do this. Okay, we'll wrap things up with problem number 77. Problem 77 in your homework. So the problem reads: we have a function minimize w is equal to 20y1 plus 20y2 plus 18y3. And remember, it says here, right over here, okay, my three variables are greater than or equal to 0. So y1 and y2 and y3 cannot be negative. They are not negative numbers. And these are my constraints. These are my restrictions. So 40y1 plus 20y2 plus 20y3 is greater than or equal to 640. 10y1 plus 10y2 plus 10y3 is greater than or equal to 240. And 10y1 plus 15y2 plus 10y3 is greater than or equal to 240. And of course here we can see, we can see that the variables y1, y2, and y3 have to be non-negative. Okay, so let's set this up. Hold on 1 second. There we go. What I'm going to do, well, we're going to use duality. We're going to use duality, so I have to convert this into the equivalent maximization problem. And I'm going to use some fancy Mathematica commands to make that happen. I'm going to use some fancy Mathematica commands to make that happen. So we're going to start with clearing A. A is equal to, I'm going to copy this matrix the way that I see it. 40, 20, 20, 10, 10, 10, 10, 15, 10. And of course, remember, we have to use duality, so this matrix is going to have to be changed. Okay, it's going to have to be changed. Okay. So, first of all, instead of putting these values at the bottom, instead of putting these or the negatives of those values in the bottom row, I'm going to have to put the negatives of these values in the bottom row. All right? So how do I do that? Well, A is equal to, well, let me make, okay, before I make this change permanent, okay, insert, well, I think I remember how to do that. That's okay. So A is equal to insert A. So I'm inserting a new row into matrix A, negative 640, negative 240, negative 240. And that's going to be the fourth row of my matrix. Okay? Now this matrix has 4 rows, which means I'm going to have to augment it with the 4 by 4 identity matrix. All right? So join matrix A, identity matrix 4. Okay, and remember, I have to use the number 2 because I'm dealing with matrices and not just regular linear lists. All right, matrix form. Okay, and then don't forget, I need to put in these values as well. I need to put in the values, the coefficients from the original objective function. So A is equal to join A, 20, 20, 18, and don't forget, of course, 0. Don't forget that too, otherwise you're going to have problems. Oops, 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 oops. Okay, we made a mistake. Let me, oh God, hold on a second. So clear A, let me do this again. Let me do this again, Shift Enter, Shift Enter. Okay, so there was a problem here. All right, one second. Why did that not work? Okay, hold on a second. That's really weird. Hold on one second. Matrix form. Okay, that looks good, but I have to add that column. Why didn't that work? Why didn't that work? It's really strange. Okay, let me try this without saving my answer in A. 20, 20, 18, 0. Okay, so it worked that time. I don't know what. Okay, I did something wrong before. Okay, so that looks just fine. Okay, so I'm going to save my answer in A. And okay, there we go. Save the answer. Okay, there you have it. So let's solve the problem. Let's actually solve the problem. Okay, so this is this column has the most negative value in the bottom row. One second. There we go. This column has the most negative value in the bottom row, so that's where I'm going to pivot. I'm going to pivot in that column. Okay. So we have 20 divided by 40. 20 divided by 40 is 0.5. and 20 divided by 40 is 0.5, 20 divided by 10 is 2, and then 18 divided by 10 is 1.8. Where is the minimum quotient? Where is the minimum quotient or the minimum ratio? It's right over here. Okay, so that means I have to pivot right over here on that 40. Okay, so let's do it. The first row is equal to 1 over 40 times the first row. Okay, fantastic. And then we need to remember we're using, Gaussian elimination. So the 10 has to become a 0, the 10 has to become a 0, the negative 640 has to become a 0. Okay? So the second row is equal to the second row minus 10 times the first row. And then the third row is equal to the third row minus 10 times the first row. And then the fourth row is equal to the fourth row plus 640 times the first row. Okay, so then we look at the bottom row, and great, there aren't any negative numbers in the bottom row, right? So I'm looking at these values right over here. Don't worry about the last two values. Remember, we talked about that. I talked about that in a couple of my previous videos. You're looking at the values right over here. All the values in the bottom row except for the last two values. So are there any negative numbers? Are there any negative values? And the answer is no, which means you're done. You're done with the algorithm. You have reached your optimal solution. Okay, so then think about, what are my answers? Okay, what are my answers? So, okay, let me make sure I remember this. Okay, so this is basically, okay, in the dual problem for the maximization problem, this would be your x1 column. This is your x2 column. This is your x3 column. And then you have these three slack variables, but those correspond to the decision variables of the original minimization problem. Okay, that would be y1, y2, and y3. Okay, and the way to check is, well, if y1 is 16, and if y2 is 0 and y3 is 0, w should be 320. Now let's see if that's true. So 20 times 16 plus 20 times 0 plus 18 times 0, that gives me 320. And let's make sure that those constraints are true. So 40 times 16 should be greater than or equal to 640. Okay, 10 times 16. Oh, that might be a problem. Wait a second. If we have 10 times 16... that might be, hold on one second, so 10 times, yeah, that doesn't seem quite right, because 10 times 16 plus 10 times 0 plus 10 times 0, that's 160, but that's not greater than or equal to 240. And then again, 10 times 16, that's 160, but that's not greater than or equal to 240. You know what? I'm not sure if this problem makes sense. I'm not sure. I mean, I'm not sure if my answer makes sense. I'm not sure if my answer makes sense because the last two constraints, they don't seem to make sense unless I made a mistake setting up the matrix. Whoa. I did make, okay, there is a mistake. Yeah, and I see, okay, hold on, I have to backtrack. I think I see, wait a minute, I think, yeah, so I may have to redo this problem from the beginning, guys, because here's my mistake. Okay, now, yeah, this is not the correct answer. This is definitely not the correct answer. Because, this is not the correct answer, and I know exactly what my mistake was. I know exactly what the mistake was. What I forgot to do, guys, remember I have this matrix here, 40, 20, 20, 10, 10, 10, 10, 15, 10. Okay, I need to take the transpose of this matrix. I need to interchange the rows and columns. So this problem is not correct. So we need to do this over again, okay? So sorry about that, but that was definitely a mistake. So we're going to clear A. Let's start this problem over again. Problem 77, we're doing this over again. So A is equal to 40, 20, 20, 10, 10, 10, 10, 15, 10. Okay, but this is important. I need to take the transpose of that matrix. That's what I didn't do before. That was a mistake. All right, matrix form. Okay, so the first row becomes the first column. The second row becomes the second column. The third row becomes the third column. So I hope you guys can see that. The first row becomes the first column. The second row becomes the second column. The third row becomes the third column. Okay? That's what the transpose does. All right, that's important, and that's what I forgot to do the last time I tried to solve this problem. So, yeah, I made a mistake in my first attempt, but you know, that's okay. Teachers make mistakes too. Okay, so then everything else should be okay. So let me see here. A, insert A, and that's going to be negative 640, negative 240, negative 240, and that's going to be the fourth row of my matrix. Okay, and I'm going to join that with the 4x4 identity matrix. Okay, and then let me, before I save my result in A, let me make sure that it works out okay. We have 20, 20, 18, and then 0. That looks great, so let's save the answer in A. Okay, and now finally, okay, this looks a lot better, so yeah. I forgot to apply the transpose to my matrix, guys. So when you're doing these duality problems, you have to transpose you have to transpose the matrix of coefficients, because otherwise you're not going to have the right answer. Okay, it's just not going to work. Okay, so let's get started. 20 divided by 40 is 0.5. And 20 divided by 20 is 1. And 18 divided by 20, what's 18 divided by 20? Let's see, what is 18 divided by 20? Well, that's the same thing as 9 divided by 10, so that should be 0.9, right? That would be 0.9. Okay, so 20 divided by 40 is a half, or 0.5. 20 divided by 20 is 1. 18 divided by 20 is the same as 9 divided by 10, which is 0.9. The minimum ratio is right over here, 0.5. So I'm going to pivot right over there. Okay. So how am I changing the first row? We're going to multiply by 1 over 40, first row. Matrix form, okay. And the second row, the new second row is equal to the old second row minus 20 times the first row. Okay. And the new third row is equal to the old third row minus 20 times the first row. And then the fourth row is equal, the new fourth row is equal to the old fourth row plus 640 times the first row. Ugh. Okay, that's just so distracting. Sorry, guys, but there's nothing. Chach, enough. Stop. Stop. Stop, stop, stop. Sorry, guys, but, you know, I'm not going to get rid of my dog just to accommodate some classes at Oakton College. I mean, you know, my students are important to me, but my dog is also very, very important to me. So we're just going to have to tolerate, you know, some distractions while I make these videos for you. Okay? All right, so that looks good. Okay. So now we can pivot either in the second column or third column. It doesn't really make a difference. Hey, Chachk, I'm busy. Okay. Okay. So it doesn't really make a difference. There's a tie. So we can pivot in the second column or third column. So I'm going to choose the second column. Okay. So let's see. 1/2 divided by 1/4, that's going to be 2, and 10 divided by 5 is 2, and 8 divided by 5 is 1 with the remainder of 3, 1 3/5, so what is that, 1.6 I think? 8 divided by 5 is 1.6, I believe. Let's see. 8 divided by 5, 1.6. Okay, so the minimum ratio occurs right here, which means I'm going to pivot right over there. Okay? So let's see. I'm changing the third row, 1 over 5 times the third row. Okay, and then the first row, one second, is equal to, the new first row is equal to the old first row minus 1/4 times the third row. Okay, and the new second row is equal to the old second row minus 5 times the third row. And then the fourth row is equal to the fourth row plus 80 times the third row. make sure we're okay with that. Yeah, that should be fine. Okay, that looks much better. Okay, so let me make sure. Okay, that looks much, much better. So again, guys, look at your slack variable columns. Your slack variable columns contain the answers to the original problem. So here we go. Right over here. Okay, so that means y1 is going to be 8. Y1 is going to be 8, y2 is going to be 0, and y3 is going to be 16. And let's see if that's true. Chach, what's going on with you? I'm talking to my dog, guys. Sorry about that. So y1 is equal to 8, y2 is equal to 0, and y3 is equal to 16. Okay. So 20y1 plus 20y2 plus 18y3 should be 448, okay, which is a good way of checking. Excuse me. That's a good way of checking if you have the right answer, okay. 40y1 plus 20y2 plus 20y3 should be greater than or equal to 640, which is true. 10y1, oops, 1 second, 10y1 plus 10y2 plus 10y3 should be greater than or equal to 240, and that's true. And then 10y1 plus 15y2 plus 10y3 should be greater than or equal to 240, so that's good. So just checking my answers. So the minimum solution is w is equal to 448 and occurs when y1 is equal to 8, y2 is equal to 0, and y3 is equal to 16. So the minimum solution, the minimum solution is w is equal to 448 and occurs when y1 is equal to 8, y2 is equal to 0, and y3 is equal to 16. So yeah, my dog is real happy now. So people came into the house. So it's a good thing we're almost done with the video, guys. Okay, so that's it. I'll make another video in a few more days, and I hope this was very helpful for you, okay? All right, thanks. And, well, let's check the answer first. The answer is correct. Okay, sensational. But just remember, my original mistake was not taking the transpose of the coefficient matrix. You have to do that. You cannot forget to do that, okay? Okay, guys, that's going to be it for today. And I will try to make another video in a few days going over some more of these problems for you, okay? Take care. Enjoy the rest of your day. Have a good day. Bye-bye.